Okay, we're going to start building up some stuff to get into proofs, and we're going to start with our segment and midpoint things, postulates, theorems, and whatnot. So, first of all, talking about what a postulate is. A postulate is just something that's accepted as true. It's kind of our beginning. Just like we had a point, a line, and a plane that were undefined terms to use to explain defined terms, we have postulates to explain all our other things. Our axioms and postulates just are. They are because we said so, basically. So if we keep moving down here, we're talking about, we have a ruler postulate. We don't need to worry necessarily about that term, but we should be able to use a ruler and measure. So if we have 2 points A and B on a ruler and want to find the distance, no matter where they are, here we're starting from 0 going to 5. Of course, this is 5 inches. And again, we need units. But if they're not right on the starts at 0, it's 2 to 7, of course we can count it. We can count that it goes up 5 times or subtract it, but like we discussed last week, we have to take the absolute value because we can't have negative distance. So 7 minus 2 is 5, or 2 minus 7 is negative 5, but we take the absolute value, which is 5. Now again, when we're talking about the distance or length of segments, we don't use the segment symbol like we see here. If we're talking about the segment, we use the segment symbol. That's very important to see the difference. So for example, AB, the measure of AB would be 5, and maybe CD is 5. So segment AB is congruent to segment CD. Notice we don't have the segment symbols here because we're talking about measurement. Instead of putting an M in front of it like we will for angles, segments, we just leave off the segment symbol. So if we're going down here to look at number 1, determine the length of each segment in centimeters. I don't have a ruler that I can show on the computer, but I believe that we know how to use a ruler. So say that we get DE is 2.5 centimeters, EF is 5.7 centimeters, and DF is 8.2 centimeters. Just measuring, nothing too crazy, nothing ridiculous going on there. We're going to do that again for number 2 here. So KH is 4.9 centimeters, still says centimeters, and I still want units. 5.7 centimeters is HG, and GK is 10.6 centimeters. So it says, using results from items 1 and 2, describe any patterns that you notice. We can just look at the second one. We can scroll up the first one and see it as well. But you should be able to realize that the sum of the two smaller segments is the measurement of the bigger segment. .9, which was this part, and 5.7 is this part, is G, gives us the whole thing. So when you add up the parts, it gives us the whole segment. And that is very important. That is our segment addition postulate. And you add up the smaller parts of a segment, you get the whole thing. So not anything too crazy or out of the ordinary, but we do have a name for it that we'll have to use in proof, so you need to know this. So I'm going to star that. All right, if we're given the lengths MN and NP, given that N is a point in between M and NP of line segment NP. Now what I suggest for all these problems, even though they sound simple, is to draw it out. So segment MP and N is a point in between them. We don't know exactly where. I made it look like the middle, but it doesn't have to be. Describe how to determine the length of MP without measuring if we are given MN and NP. So very simple, MN plus NP equals MP. Notice I don't have the segment marks over top because they're not segments, they're the measurements. We can't add segments, we add measurements. And we could have rearranged this so we could find the smaller parts if we had the bigger parts and so on and so forth. Again, I think the writing it out makes it easier. It even says draw a sketch. I really suggest that you do that. It makes things a little bit easier. They use a segment addition postulate and give them information to complete each statement below. So we have B between C and D. So BC or CB is 10. BD is 3. Then CD is the whole thing, 10 plus 3, 13. Again, not difficult, but I don't want little things like this getting in the way. Oh, 13 inches, don't want to forget units, because we just looked at the problem wrong or did something silly. So again, Q is in between R and T. So the whole thing R at T is 24, and QR is 6. So how do we find QT? Well, using our segment addition postulate, 6 plus something, or x, equals 24. So we subtract using the subtraction property of equality. So x equals, which is QT, 18 inches. Oops, no, it's not. It's centimeters. So make sure that you're using the units that they give you. Now, if P is between L and A, so L, A, P is somewhere here. PL is x plus 4. PA is 2x minus 1. And LA, this whole thing, is 5x minus 3. We got to solve for x and find LA. So we don't know what the measurements are, but we know that the smaller segment, LP plus PA equals LA, the whole thing. So using our substitution property, we're just going to substitute in those values. So LP is x plus 4, PA is 2x minus 1, equals LA, 5x minus 3. Combine our like terms, which we are writing a proof. There is no such thing as combining like terms, but we're not, so we don't have to. We're going to subtract 3x from both sides. You get 3 equals 2x minus 3. Add 3 to both sides. 6 equals 2x. Divide by 2, and x equals 3. If we had to write a proof, remember we'd have to switch these around using our symmetric property, but again, that's not what we're doing. X equals 3, and we're looking for LA, so the whole segment. So we could plug it or substitute it into each one of these separately and then add them up, but the easiest way to do it, again, is using substitution. And substitute 3 in for x in what LA equals 5x minus 3, so 5 times 3 minus 3. And LA equals 12. And it does not look like we have units, so I'm just going to write units down here. We want to be careful that we're answering the question. Next, we're going to talk about the midpoint. We kind of already talked about this last week. The midpoint of a segment is the point on the segment that divides it into two congruent segments. And again, you already know what congruent means. It means they have the same measurement. Now, midpoint does that for a segment. So if B is the midpoint of AC, then AB is congruent to BC. They're both 3. We can see that. So given M is the midpoint of RS, complete each statement. Again, it's something very simple, but I suggest that you write this out. We cut down on our mistakes, and this is not difficult. I don't want us to lose points on something that's pretty simple. So M is the midpoint. We know that this is congruent to this. Remember, you can write it with those tick marks. And we have that congruency statement going a little bit farther than what we really need to. But if RS is 10, what is SM? Well, something plus something is 10, or really we just have to divide it in 2 because they're equal, so SM is 5. Now if RM was 12, then MS is also 12 because they're the same, and then RS would be all of that combined, so 24. Again, not very difficult, but I suggest you write it out. We will do 7 through 9 in class. We're not going to do number 10. I guess you can guess why. We can also find distance between 2 points on a number line. That's kind of what we did with the rulers. So again, the distance is the absolute value of their difference. So subtraction, no matter how you do it. So it's either -3 minus 4, which is -7, or 4 minus -3, which is 7, but absolute value is 7. So there's 7 units. LM is 7 units. Again, no segment symbol over the top. The midpoint of a segment is halfway between its endpoints, so if you know the coordinates of the endpoints, you can average them. Again, average, like we talked about the midpoint formula, to find the coordinate of the midpoint. So when we find the average, we add them up and divide by 2. So 40 plus 8 divided by 2. So it's 48 divided by 2, so 24. That is my midpoint. And you can see that, again, 24 minus 8 is 16. 8 minus 24 is -16, but take the absolute value. So we can find each of these. 13 will be our warm-up in class. Here's an example that I do want to run through. Notice that they have these. They will be very important when we get to the proofs at the end of this week and the beginning of next week. I don't think we need them for every single problem that we're doing, unless it says justify your steps. Q is the midpoint of PR. Again, the book doesn't, oh, they do have it down here, but that's after the fact, so I want to write it before. P, R, and Q, and these are congruent, so whatever they are, they're the same. PQ is 4x minus 5, QR is 11 plus 2x, and we want to find PQ. So the first thing we have to do, well, we have to know that these two are the same. PQ is equal to QR. So by the substitution property, we put in their measurements, 4x minus 5 and 11 plus 2x. Use the subtraction property of equality, we subtracted 2x. Again, in a proof, we wouldn't write out the work. Then we use our addition property of equality, we're adding 5 to both sides. Then we're using division property of equality, we're dividing by 2 to get x equals 8. But that's not what the question asked. It said find the length of PQ. So we had to do that, but now we substitute that back in here. So 4 times 8 is 32, minus 5 is 27, and it's 27. Make a sketch of PR and its midpoint, so we can see it. That's 27, that's 27, and together it's 54. We will try and do this one in class tomorrow. We will also do 14 in class and the rest. So if you have any questions, you can always email me, but that is 4.1.